Okay, hello. So in the previous lesson, I have introduced to you some of the components in a lens's ray diagram and some of the rules that we are going to use to help us draw the ray diagram. Now, so some of you are asking me, teacher, why do we need to learn this? What is the function of this? So basically, you need to first understand what is the function of the lens. Okay, so basically, if you look at the screen here, the lens basically enables the refraction of light. So if we have a illuminated object here, and the light from this illuminated object will go in all directions. So down here in this diagram, I'm showing you only two of these light ray emitting from this candle flame. So what happens is that these two rays will go into the lens and then it will undergo refraction. But because of the shape of the convex lens, it will actually refract the light in such a way that it will converge at a particular point. So in this particular diagram, I'm only modeling it with one point. So every point along this candle is emitting light. Okay, it can be emitting light or reflecting light from another light source. So all this light, it is like a signal. So this is the input signal. So the signal come out and then go through the lens, and then all this signal will converge back to one singular point. And at this very instance, so every point on this candle is doing just that. So all these points will be converged along this plane, and therefore you will see that the object will form an image down here. Now, why do we need to learn how to draw this ray diagram? Is because by placing your candle at different distance from the lens, you can see that the image would move. And actually, you can form an image on a screen, like this case, right? You can form the image on the screen, just like what I showed to you on the projector. So by shifting this distance, you can see that the image formed on the screen can become blur. Okay, why is it blur? Because this point B forms two different points on the screen, right? Because actually the point B will only converge at this distance. But if you go and put the screen here, the point B, the signal will be dispersed. So that's why you will see a very blurred image. So as you can see, as I bring the candle closer to the lens, my image will also shift. When the image, or should I say when the convergent point, okay, what do I mean by convergent point? This point, the point whereby the pink and the white line converge. Okay, when this convergent point is on the screen, you will see a very sharp image. Okay, let me try and make it sharp. Okay, I think because of my mouse, I cannot get it sharp, but you get the idea. So by changing this object distance, okay, you can form different types of image. You can form such that it is of the same height. Okay, when it is diminished, I'm saying the image here now is diminished, same size as the object, enlarged image, and even a virtual image formed without any screen. So that's why we want to study the ray diagram of lenses, so that we can determine how far we should place our lens, or how far we should place our object to form the image that we want. Okay, so let's do a quick recap on some of the rules that will help us draw our ray diagram. Okay, let's begin. Okay, first, a quick run through. Remember your lenses. Okay, it has a double arrow. Okay, then after that you will have your principal axis. Basically, it is a horizontal line cutting through the optical center of your lens. Okay, then after that we will have our focal point. Okay, of course, you will have another term which I've forgotten to put onto my slide, is actually the focal length. So the focal length is basically the distance between focal point and the lens. And of course, you will have your focal plane. Now remember, convergent point is not necessarily the same point as focal point. Okay, they are different. So this is rule number one. Whatever light ray that has passed through the optical center will not go through refraction. Okay, they will just pass through straight. And then we also know that if the light ray is parallel to the principal axis, after it goes through the lens, it will be refracted towards the focal point. And the third one is that if we want to determine where the image is, we just need to locate the convergent point. Okay, so this is the convergent point where the two light beams intersect. So this source A would appear right here, meaning that once we determine this point, any ray coming from source A will be refracted towards it. Okay, any ray, okay, will be refracted towards it. Okay, then after that, we also have the reversibility of light, meaning that if I have a parallel line, a line parallel to the principal axis, it will go towards the focal point. But the reverse is also true. If I have a light beam that cuts through the focal point and into the lens, it will then be refracted in such a way that it is parallel to the principal axis. Okay, this is what we call the reversibility of light. Okay, then after that, we also learned that if there is a source of light far away, giving you a parallel beam, if these beams are parallel, then we can tell for sure that they are going to converge somewhere along this focal plane. Focal plane is basically a vertical line drawn through your focal point. Okay, so this one I demonstrated it to you in class. Okay, so meaning that all these points will be converging there. And of course, like what I said, if I construct a line parallel to all the beam and cuts through the focal point, then it will be refracted in such a way that it is parallel to the principal axis, which is also true. So they will all intersect at the same point. Okay? Okay, so now with all this knowledge, what is the use of it? Well, the use of it is that we can then deduce that by placing the object at different distance from your lenses, you can get different types of image. Now, what do I mean by different types of image? When we talk about image, okay, there is this thing called image characteristic. Okay, in layman term, basically it means the type of image. We are going to comment on the size. We are also going to comment on whether it is inverted or upright. Okay, we are also going to comment on whether it is real or virtual. Now, the word real and virtual is just a fanciful scientific name of saying that whether the image can be formed on a screen. Okay, and I give you two classic examples last lesson. Your projector is projecting on a screen. So meaning that the image produced by the projector is real because it can be formed on a screen. How about the image produced by your glasses? Well, you wear your glass, you can see a very sharp image in your eyes, right? But if you go and put a piece of white paper behind your glasses, can you see any image formed on the paper? No, right? So we say that the image formed by the pair of glasses is virtual because the image doesn't appear on any screen, but you can see it. Another example is your magnifying glass. If you put your magnifying glass there, when you see through the magnifying glass, you see a magnified image. But if you put a paper behind it, you see nothing. So virtual simply means that the image cannot form on a screen. Simple as that. Okay, as for size, I think you all know whether it's enlarged, same size or small. So if you go and put your object, okay, at a distance of 2f from your lenses, what you are getting is that you will be getting a image of the same size. Okay, go and refer to your textbook page 242. You will have all the different combinations. So I will show you where I get this information. Your page 242 looks something like that. So what I'm showing you on the PowerPoint is this case. U stands for object distance. Okay, so when the object is 2f away from the lens, you will also get an image that forms at 2f and the image is same size. Okay, and what is the characteristic of the image? Well, we say that this thing, it is inverted, it is going to be real, okay, and it is same size. So what is the application? Well, photocopier. Okay, so this is how you make use of your page 242. So let's go back to our slide. So let's look at the second configuration. Second configuration, I bring it slightly nearer to the lens. So now my object is said that it is between 2f and 1f. Right? This is 1f, this is 2f away, right? Just now I was here. So now I shift my object slightly to this position. So we say that now the object is between 1f and 2f. So by drawing the ray diagram, you can see that the image form will be slightly larger. You can also see that it has moved further away from the lens. Okay, on your worksheet, I make that worksheet so that the reference is the same throughout. The lens is in the same position. But so by drawing it on the worksheet, you can see that the image will have moved away. So as the object moves towards the lens, your image moves away from the lens. And you can see that the image is slightly larger. Okay, so referring back to your page 242, what I'm trying to say is this case. Okay, when the object is between f and 2f, and you can see the image property here, image characteristic. What is the use of it? Right, to enlarge something. So it is like a projector. So we have many different configurations, and you have to study all of them, because sometimes the MCQ expect you to actually have these images in your mind so that you don't need to sketch it. Well, if you are like me who cannot remember much, I always sketch, but I make sure that I sketch very quickly. Okay, so now instead of moving the object towards the lens, I move it away from the lens such that it is more than 2f. So if you move it away from the lens, you will see that, okay, your object will become, your image will become smaller. Okay, it is still inverted and it is still real, meaning that it can still form on a screen. Okay, so the application, I think, if I'm not wrong, is camera. Okay, so you can see that there are many different configurations. This is the fourth one. So just now we have the object at 2f, which is the first configuration. Then I move it slightly nearer, which is between 1f and 2f. After that, I move it further, okay, more than 2f. So now what I will do is that I will move it such that it passes the 1f. So when we pass the 1f point, you will see that on the right side of the lens, this side, the two lines will never match, right? It will still move further and further away. But if you trace it back, you will see that there will be a converging point down here. Now, you also notice that I draw on this side dotted line. We call this the virtual ray. Okay, down here is where the light ray is moving. This one is what we call a virtual ray. Okay, so when these two virtual rays converge, it will actually form a virtual image. And you can see that even for the image, I'm using dotted line. So remember, important, okay, for you to draw your ray diagram, solid line means that it is a light ray, a real light ray. This light ray will form on the screen. Okay, if you want to show virtual image, it has to be dotted. Anything to do with virtual, it has to be dotted. Roger? So you can see that this image is much more bigger. It is magnified and it is upright. So what is the application? This is exactly your magnifying glass. If you go and place your magnifying glass there, you will see that the image is upright, right? It is not inverted and it is much bigger. Okay? And the image is formed in your eyes, right? Your eyes perceive the image directly. There's no need for any screen. Okay? And of course, you also have the last case, which I didn't put it on my worksheet. Okay? So, just now, before, when I'm at the PowerPoint, I'm talking about this case. Okay? Then this is the case whereby it is in between, exactly at 2f, further than 2f. Okay? In your textbook, there is one more. Okay? That is when it is exactly at 1f. Okay? This one, you go and see for yourself. You will see that the light will not converge at either the right or the left side. It will just never converge. And it is used to produce a parallel beam of light. For example, your searchlight. Okay, so familiarize yourself with all these configuration of ray diagram, lenses ray diagram. Okay, remember those image characteristics. It will help a lot when you are trying out the MCQ question in your 10-year series. Okay, so let's carry on and try out some questions. Okay, first question. In this case, they didn't give you the focal length, okay, but they give you the object distance. They also tell you the object height and the image height. So your job is to find this focal point and make sure you mark according to the question requirement. If the question want capital F, give capital F. So how to do? Well, remember all light starts from the object. So you always start from the object. So the easiest ray to do is the ray that passes through optical center, because it will not change direction. So draw that ray first. So draw it. Okay, and you see that, well, I draw a scale diagram, so the lines should be able to align themselves. So you know that, oh, by this line, I know that my image should form here. Meaning that if now I construct a parallel light down here, how shall this light bend after it passes through the lens? Okay, I will give you 5 seconds to think. Yup, very good. Okay, because the image is down here, it means that the light must converge at this point. If it doesn't converge at this point, you cannot get an image right here, right? So I know that from here, I need to draw a line from here to the image. Then some of you may be asking, teacher, but I thought you said if the light is parallel to the principal axis, this beam of light should cut the focal point. Yes, but the thing is that the question didn't give us the focal point, right? So we cannot use the rule directly. We need to modify it, right? We need to modify it through our understanding. Our understanding is that as long as the image is formed here, meaning that the convergent point must happen here. So instead of drawing the line from here to my focal point, which is non-existent, I have to draw the ray such that it converge at this point. So I will draw it here. So once I draw it here, I can then make use of what you have said just now. Parallel beam, after it goes through the lens, must cut the focal point. So where is my focal point? Here lor, focal point. So I label it F. Understand? Okay, if you don't understand this, make sure you come and look for me. This is the basic. Yeah? Okay, now if I modified my question and ask you, give me the focal length. Should I stop here? No, this is focal point. If I want focal length, make sure you label it here. Measure it. Roger? Okay, let's move on to the next question. Oh, I also want to teach you this secret maneuver. Okay? After I teach this, you can solve all ray diagram question without even need to draw the diagram. But in O-level exam or in school exam, you cannot use this formula. You cannot use this formula and let me know that you are using this formula to find the answer. You can use this formula to find the answer, but you cannot let the examiner know that you are using that formula. Okay? So, what is the secret formula? The secret formula is actually the object distance, the image distance, and the focal length is related by a formula. So, let's say you are asked this question and you are very lazy, you don't want to draw this diagram. What you can do is that you can substitute all the values into this formula. 1 over object distance will be equals to 1 over image distance equals to 1 over focal length. Okay? This thing works for all cases. Now, some of you may ask me, teacher, but what if they give me the object distance, but they never give me the image distance and they want me to find the focal length? Then how can I use the this equation to find it? Well, your mathematics has taught you similar triangle, right? So let me show you. Look at this yellow triangle. Can you see another similar triangle in this drawing? Here lor. So if you go and write down all your terms, object height, object distance, image distance, image height. They are similar triangle, right? Meaning that you can relate them by this formula. Okay? So basically with this formula and this formula, you can solve all the ray diagram questions without drawing the ray diagram. Now, then teacher, then you may ask me, teacher, then you told me I cannot use this formula. Well, you need to be smart, okay? Meaning that if you are asked to draw this ray diagram and you have no idea where to start, let's say they ask you to find the focal point and you have no idea. So what do? Well, you go and measure all the object distance, object height, use this equation, find the focal length, take your ruler, measure from the lens that focal length. Well, you find the F, right? Once you find the F, you just reverse engineer the answer for me lah. Understand or not? Okay, if you are still not sure on how to use this formula, come and ask me, okay? Reverse engineering, you know, just Google it. That means you go and find the answer and you work backwards such that it looks as if that your working lead you to the answer, but actually you are playing cheat. Understand or not? Okay? Okay, part B. Complete the ray diagram. Okay, this one pretty straightforward. Okay? To determine the image distance, right? And all these are parallel beams. Okay? Now you can see this beam or not. This beam, as long as you see parallel beam, it gives you a lot of information. If this beam becomes parallel to the principal axis after passing through the lens, what does it say about this point? It tells you that this point is the focal point, right? This point is the focal point, right? And you know that your focal point on the left is at equal distance at the right. So if I am smart, okay, I can tell you that, okay, I can tell you that this must be F. I measure this distance, give me the same distance here. This one will be my F. Then I remember one of the laws says that if I have parallel beam of light, it will definitely converge on the focal plane, right? So can you see that this line already converge at the focal plane? So I know this is my focal convergent point already, lor. Right? So I solved the question, right? My image will form here. I can find the image distance. Now another slower way is that, well, draw the line that cuts through the optical center. Oh, you see? Once I draw it, you can see that it is very close to that same point also. Right? So once you draw this line, you can see an intersection, right? Well, that becomes your convergent point, lor. Right? Oh, sorry, I didn't measure, so I think this one salah. Okay? Can? So I erase this so that it don't confuse you. Okay? I didn't measure, so maybe that's why it is not 100% matching. Can? So you will have the sorry. What to do? Keep? No, discard. Yeah. Press wrong. Okay. So this is the convergent point. So if now I ask you where is the focal point, can you answer me or not? Where is the focal point? Well, some of you, this is a trick question. Some of you may jump to a conclusion and say that this is the focal point. Wrong. Okay? Why wrong? Because is this line parallel to the x-axis? No, right? So where's the focal point? Focal point is here. Okay? If you want the focal point on this side, then you have to tell yourself, remember, all the light will converge at the focal plane, right? So actually, here is your focal plane. This is your focal point. Then some of you may ask me, teacher, then should I write the focal point on the right or on the left of the lens? It's the same. Okay, it's okay. Okay? So that is your ray diagram. Now I will just do one more example to put you at ease. No, two more. Okay, this is the last part of your class worksheet. So it's the same thing. I have an object here. I put a screen here. This is the focal point of this lens. So now I need to determine where is the image and why is it out of focus. Okay, so I will just draw the standard. Okay, why is it like that? So I will just draw the standard. Okay, one ray go through the optical center. Wrong. Where did I go? Okay, now. Okay, so I draw through the optical center, it goes straight. The second ray is always a parallel ray. Parallel ray, right, to the principal axis. So it will bend to the focal point, cut through the focal point. Can you see that my convergent point is slightly in front of the screen? So it will look something like that. So in this case, it will look like this. Okay, it will look something like this. Okay, whereby my image is slightly in front of the screen. So can you see that on the screen, it will be blur? Yeah, because my point B forms two images on the screen at this distance. Yeah, so because of that, the image is blur. So after that, the question asks you how to adjust this so that you got a sharp image, right? So remember, if you bring your object nearer to the lens, the image will move further away from the lens until the image forms sharply on the screen. You can stop, right? So I demo again. At first it is like that. my image is in front of the screen. So what you do, you bring the object nearer to the lens so that the image will move away from the lens until it is on the screen. Okay? So that's how it works. Let's move back to the slide. Okay, now I will use one question from your homework and show you how do I go about solving it. Yeah? Okay, let's move to your homework. Let me add one slide. Okay, your homework. Let's do question 6. Okay, I will show you how to do question 6. Okay, question 6. Now, the idea of ray diagram is ray diagram usually consists of 3 marks. The more information you can re-represent from the question context to your ray diagram, the more points you get. Even if you do not know how to solve it, just by re-representing the data from the question to the graph, to your diagram, will give you points. So what do I mean by that? If I look at this very straightforward answer, I will see that I am given 3 sets of data. How come like that? I'm given image distance, object distance, image height. As long as I can re-represent this data in a graphical manner in my ray diagram, I score marks. Okay, so let's try. Okay, let's bring this here. Okay, first thing first, I would always need to draw my principal axis. So I'm just going to quickly draw my principal axis. Then after that, I have to draw my lens. So I just go and draw my lens. Okay. Ta-da! Half a mark. Finish. Okay. Remember double arrow. So now I need to know, I don't know what I need to find. Normally I don't read my question. I just want to re-represent my data first. So I know that it is 2.4. So what to do? Okay. I don't have a ruler. So what I'm going to do is that I'm going to use my PowerPoint skills. So 2.4, right? 2.4. Okay. This color, let's change it to red. Okay, this red color thing is going to be my ruler. Okay, I have just set it to 2.4. Can you see here? So this is my image distance, right? So let's call this image distance. Okay, this is my image distance. Yeah, so I put it here. I don't know how high is my image. I don't care. Okay, I just write down this is my image distance first. Okay, meaning that I already know my image is going to be along this line. Okay, I can draw many lines on it to help myself. So just dotted. Oh, too small the dot. Like that. Can see? So I know my image is going to be somewhere around here. Okay. Oh, it is virtual. Virtual means that it is on the left side. Okay, let's make this question easier. Let's say I want this to be virtual. Okay lah, virtual. Let's try virtual then. I don't know whether it will work or not. Virtual image distance. Virtual is here. Okay. Virtual is on the left side of the real is always on the right. Okay, then after that, I want to tackle the object height. Object height 1.4. But I don't know where is my object, right? Never mind. I am going to label it first. So 1.4. Wow, I'm going to have a very tiny one. Okay, I'm going to have a scale. Okay, let's make a scale. If not, my this thing will be very small. My scale is 1:2. Okay, so meaning that my image distance 2.4, right? I want to scale it up by 2. 2.4 times 2 is 4.8. Okay, so now this is my image distance. My image will be somewhere here. Okay, my object height. I don't know what is my object height. I don't know where is my object, but I know my object height is 1.4. So a scale of 1:2. This one become 2.8. Okay, so my object will be somewhere, okay, along this line. Okay, I don't know where's my object. Image height 2.3. Okay, so I know how high is my image. 2.3 times 2, 4.6. Right, is image height, so rotate. So my image will be here. Right, I know my image distance, I also know my image height. So meaning that now I can construct my image directly lah. So this one will be my image. Image, make it blue. Okay, and single arrow. Right. Yeah, and I know that it is virtual. Virtual means that it has to be dotted line, right? Dotted line. Okay. Okay, I still do not know where is my object. Okay, so if let's say I leave my question like that, okay, I just need to label properly. This is my object height. Yeah, I'm just making labels. Okay, let's make it a bit OCD. Okay, this is my object height. That means my object will be will be as tall as this line lah. But I don't know where is my object because object distance is not given. I also don't know where is my focal point because focal point not given. So if let's say I stop here, how many marks I get? 2 marks out of 3. Right? So even I don't solve the question, I just draw whatever I can re-represent from this. 2 marks out of 3. Correct? Sure, right? This one is a giveaway mark. You just need to have the guts, re-represent the thing, done. Okay, so now, how to solve this? Of course, as your teacher, I must be able to solve, right? Okay. Remember, the first rule is always the simplest. What is the first rule? First rule is this one. Any line coming from the optical center. Right? Now, and then you have another hint. This thing is virtual image, right? If you look at your thing, there's only one configuration that gives you virtual image. This one, right? Can you see that there will be a line cutting through from the image top, cut through the optical center? So, take the hint. That's why you need to remember the configuration. So, from here, take a line. From this dot, right? Cut through the optical center. This is the optical center, right? Cut. Can? Then, what do? There is another line, right? Oh, wait. But before you do, can you see that this line cuts through the optical center, right? Can you see that it also cut the object height? So meaning what? Meaning your object must be here lah. Correct or not? So I have to draw my object here. Right? Because remember, this light ray has to come from the object. What? If you look at down here, oops. Can you see? This line cuts through the optical center, right? It will also cut the tip of the object. So that's why you must remember this configuration. It will help you solve questions like that. So now I managed to find my object distance. Once I find my object distance, what do? Well, the other line always from the object is a parallel line, a ray that is parallel to the principal axis, right? So I will draw from here. Yeah, here. Okay, draw, cut here. Well, but I do not know. Let me make it bold so that you can see where it comes from. Let's make it into what color? Into blue lah. Okay. But I do not know from here, right? Where should I cut? Because I don't know the focal length, right? I don't know where to draw. But remember, in order for the image to form here, I must have one more ray to converge, right? Where does that ray come from? From here, lor. What do I mean? Okay, this thing. If you look here, let me. Too big. Okay, if you look here, here. Can you see this parallel light? Parallel light, it will go to your focal point. But we do not know where's the focal point, right? So we cannot go to the right. But we can go to the left, right? So you can be parallel here. Go to the left, it will converge at the image here, right? So I can go back here. Now I can draw a line from here to, don't move, to here, right? So once I draw this line, I can then extend this line a bit up, and I can cut here. Can you see that I cut here? So what is this point? Well, this point is my focal point, right? Right or not? So now this point will be my focal point. Yeah? Until now. Just now I didn't do all this thinking process, right? It's 2 out of 3. After I do this thinking process, it's 2.5 mark. Why 2.5 mark? Because I never put any arrow, I never draw the dotted line and all that. So now let's make it more prettier. So I must draw arrow, so I add in the arrowhead lah. For you all, it's even easier. Just need to draw the arrow. Where's my arrow? Oh, wrong side. Is it? Nope. Okay. Okay, as long as you have one arrow is good enough. Okay. Down here also draw, okay, I make it shorter, then you can see the arrow, okay. Down here, shorter a bit. Okay, draw arrow. Nope, not here. Arrow is here. Okay, draw arrow already. Okay, but for me a bit more troublesome because PowerPoint don't allow me to put half dotted, half not dotted. Okay, so I need to do dotted line there. Shrink it to here. Dotted line no need to have arrow. I have arrow also okay lah. Okay. Actually shouldn't have arrow. Dotted line shouldn't have arrow. Okay, then down here change to dotted line. Okay. Make it thicker so that you can see. Now some of you cannot see one. Okay, don't know why cannot see. Okay, make it thick. Here, don't know why got one extra arrow. Eh? Oh, wrong side of the arrow. Oh. Eh, how come here got one arrow? Oh, okay. Here the arrow don't balik. Okay, make it thick. Like that. Close. Chang. Oh, okay, here make bigger. Okay, so now I got 3 upon 3 mark. I have arrow. Okay, these are my real rays. I have my virtual ray. I have my virtual image. Done. Full stop. Finish. Can? Quite easy, right? Okay. So, even if your homework you do not know what to do, at least show me that you can re-represent the data in a ray diagram. Okay. Show me all this object height, image distance. Show me all this working first. Can? Then after that, I will teach you how to do. Then some of you may ask me, teacher, then the cheat how? Can I use the cheat? Of course you can use the cheat lah. If not, what for I teach you the cheat? Okay, you want to find what? Focal length, right? So I show you how to do cheat. Wow, you see your teacher so good. Cheat also must teach you one. Last time when I need to cheat, I need to think for it myself. Okay, the 2 formula. Very simple. Aiyo, must teach me. Okay, you have 1 over object distance plus 1 over image distance equals to 1 over f, right? You want to find this, right? So what do you have? You don't have object distance, never mind, write down first. Then image distance, you have 1 over 2.4, 1 over f. So one equation, 2 unknown, not enough, right? So never mind, use the second one. Second one, what do you learn? Second one, you learn object distance over object height equals to image distance over image height. Correct or not? Image distance given here, right? 2.4. Yeah? Then image height given, right? 2.3. Okay? Object height given, right? 1.4. You see, sure enough one. They must give you enough information. If not, you cannot find. So from here, you can work out your object distance. Must I work out for you? Okay lah. Give you the whole package. Okay. Everything must do for you. Aiyo. Teacher's Day, must give me a bigger thank you card. Okay. This one. then multiply by 1.4. Okay, 1.46. Don't worry, everything 3SF won't die one. 1.46 So 1.46. So once already find here 1.46 plus 1.24 equals to 1 over F. Then please remember that this is an inverse function 1.46 plus 1 divided by 2.4. Caution this is not the answer yet because it's 1 over F. So you need to 1 divided by the answer. Okay, so F equals to forgot already. 0.908. No? Done. Okay, doesn't make sense Why doesn't make sense Oh, I know why. Why doesn't work I think it's because this is virtual image. Yeah, virtual image it won't work No, will it work?